Hello and welcome everyone to my free CCNA Cisco Certified Network Associate course. So today we are going to be talking about Rapid Spanning Tree Protocol. In the last session, we talked about Spanning Tree Protocol. So we are going to see how the RSTP is an enhanced version of the STP. What are the difference between the two and how does RSTP behaves? So let's get into it and understand what we are going to be doing today. So we are going to be understanding what is RSTP. How is it different from STP that we learned earlier? We're going to understand what are the two new port status that the RSTP introduces, that is the alternate port state and the backup port state. What does these two functionalities do they have? How are they elected? How do they behave? We are going to be understanding that. And in the end, we are going to be understanding how does RSTP converge faster than the STP and if there is any delay in RSTP also. We're going to be understanding what are the security issues around RSTP. We are not going to be doing configuration this time around. We are going to be doing a configuration in a later lecture. So in the next lecture, what we're going to be doing is looking at a practical example and how to decipher what is the root bridge, what is the root port, what is the designated port, and all of that. And in the next lecture, what we are going to be doing is doing the configuration for this. So let's get into today's lecture and understand what is RSTP. So RSTP is very similar to what STP is. In RSTP also, we elect the root bridge, we elect the root ports, we elect the designated ports, and all that is the same. So everything else remains the same. But what RSTP introduces is an alternate port and a backup designated port. So because of this alternate port and the backup designated port, alternate port is the backup for the root port and backup designated port, as you have guessed it, is the backup for the designated port. So because of these two ports, if there is a failure, RSTP can quickly switch over to the alternate port or the backup designated port. And because of this, RSTP converges very fast if case there is any change in the network. Compare it to the HTTP. In HTTP, if you lose your root port or the designated port, the convergence has to take place again. Why? Because that has no backup listed and it has to go through listening and then learning. And this can take up to 50 seconds. So in RSTP, this does not happen. RSTP, the convergence is very fast because of the alternate port and the backup designated port. So as I told you, RSTP introduces two new port statuses. One is the alternate port, which acts as a backup port for the root port. So in case the root port fails, alternate port takes up as the role of the root port. And then the second is the backup designated port, which takes up the backup of the designated port in case the designated port fails. Now, like an HTTP, only the hello BPDUs were being sent by the root bridge. This does not happen in RSTP. RSTP, every switch is proactively sending hello packets. It's not waiting for the other switch to send a hello packet, but it is also sending the hello packet. So in RSTP, all the switches are acting proactively and want to know about this state. They are not waiting for the root bridge to let them know if there is any change happening or some switch has gone down. They are proactively communicating with all the other switches that are connected to them. So in case there is any change, they can notify the root bridge, and root bridge in turn can notify all the other switches as well. So in RSTP, because of all these enhancements that are over the HTTP, that one that the switches are proactively communicating with each other and they have a backup for their root ports and their designated ports, the convergence is much faster. You don't have to wait. And that seems practical also, considering that the modern networks cannot wait 50 seconds for the convergence to take place of a technology and the ports to come up. So RSTP is what we use nowadays. Although one needs to remember that RSTP is backward compatible with STP. That means if there is a switch, the older switch which does not has RSTP, it can still link up with the RSTP network, but the RSTP network in that case will work like an STP. So the convergence will be slow in that case. For right now, what you need to understand is how does RSTP's alternate port and the backup port work. So if you remember the scenario from spanning tree protocol, this is what we had. We had switch 1 and switch 2 and switch 3. which were linked to each other, and switch 3's port connected to switch 2, whereas switch 2 is connected to switch 3 was in the designated port status. Now RSTP, this is not a blocking port. In RSTP, this blocking port is basically the alternate port. So alternate port basically works as the backup port for the root port. So for in case of switch 3, in case the link between switch 1 and switch 3, which is directly connected, goes down, that means this goes down, this automatically becomes the root port. The switch doesn't have to wait for this to come into the root port status. Why? Because the alternate port status is already there. Although the traffic is blocked in a blocking state, that means there is no traffic flowing from this direction to this while it is in the alternate port state. But the moment the root port goes down, that is, this port goes down, the switch will automatically switch over from this port being the root port to this port being the root port now. So this is because this is RSTP, alternate port is already there. So the backup will come up automatically and immediately. So in RSTP, as you have understood, the alternate port acts as the backup port for the root port. That means if the root port goes down, the alternate port comes up as the root port. Now, the instance for a backup designated port may be confusing to understand at the first go. The reason being because these scenarios are very highly unlikely to happen in today's network. Why? Because this will require a hub to be in the network. And when there is a hub, the switch will be connected on more than one port to the same collision domain. And in that case, one of the ports will become the designated port and the other will go into the blocking state but will be acting as a backup port. So in case this designated port goes down, the backup will come up immediately and there'll be no downtime happening. So if you're working in the lab, this whole convergence of switching over from the root port to the alternate port or from the designated port to the backup designated port may take 1 to 2 seconds at the most. So when we compare RSTP to the HTTP, HTTP has 5 different states. It's either forwarding, it's either discarding, it's either disable, it's either learning or listening. But RSTP basically has only 2 states. One is forwarding and one is discarding. So if it's disabled or if the port is in alternate or backup state, it will be just be discarding. And if it's forwarding, then it will be just forwarding. That means it will be either root port or the designated port. It will be forwarding the frames. RSTP does not use listening or learning, although RSTP will still flush out the MAC addresses, stale MAC addresses that are in the table. So don't think that the RSTP will not flush out the old MAC, stale MAC addresses. That will still happen. That feature is still existent in RSTP as in STP. Old stale MAC addresses will be flushed out when the ports are switched from the root port to the alternate port. So like spanning tree protocol, a rapid spanning tree protocol is susceptible to security issues. That is, if the care is not taken, the security on the ports is not enabled, then a malicious actor can take over the control of the RSTP domain by making their own switch as the root bridge. And also, the malicious actor can change the topology by plugging in multiple switches into the network and making the frames flow from their switches and capturing those frames and creating security problem for your network. So BPDU card is to be used on the ports. How we use them, how do we configure them? We are going to learn this in the upcoming lectures. But right now, what you need to understand is BPDU guard basically will protect our ports from receiving any unsolicited BPDUs from the ports that we feel that should not receive the BPDU from. So this quick video about rapid spanning tree protocol and how it differs from spanning tree protocol helped you understand what is rapid spanning tree protocol. As I've already said, in the upcoming videos, we are going to do a live example. We are going to look into the configurations of the rapid spanning tree protocol. So stay tuned. Do subscribe to my channel to get the latest updates. Do let me know in the comment section below what you think about today's video. And until we meet the next time, do stay safe.